everybody, and welcome back to Advanced Functions. Today we're starting Chapter 2, which focuses on polynomial equations and inequalities. So, essentially, this is Chapter 2.1, and it focuses on the remainder theorem. In this lesson, I will go over long division, what happens and what you should do with the results of the division, as well as the remainder theorem itself. So, for long division can be used to factor a polynomial function. You might not remember how to do simple long division, which doesn't include equations, which I would highly recommend you go over before starting this lesson. But essentially, I will teach you how to do it with equations. So, of course, in this subchapter, we will start by dividing something by a binomial, which is of the form ax minus b, or if you want to simplify it, x minus b in some cases. Of course, there's some steps you should follow before you divide a polynomial function, and of course while you're dividing it, so these are it. First, you should organize the function in order of receding powers. So make sure you have like your x3s first, then x squared, and so on and so forth. You should never have them in ascending order or in random order. Then, what you should do is use the first value of the dividend and divide it by the first value of the divisor. Then, if the produced number, or the produced value is a whole number, then you should write it down. Then, using the value you found, multiply the binomial and subtract the new binomial you got from the dividend. You should follow these steps over and over again until you can no longer produce a whole number. Lastly, the values you have jotted down will be the quotient, and the leftover values will be the remainder. Again, hearing this or reading this may seem extremely confusing, but I will illustrate these steps to you on the next slide using an example. So, let's divide the function p of x is equals to 10x to the power 4 minus 11x to the power 3 minus 8x squared plus 7x plus 9 by 2x minus 3. I will be doing this in notes so you could see me doing the steps. Okay, well, let's get started. And first we have the function p of x, which is equals to the following, and we're dividing it by that. So the way we set it up is we have 2x minus 3, which is the divisor, separated by this wonderful contraption. Also, I made it this long so it could fit the whole dividend into it. And now we write the whole dividend. So we have 10x minus 10x to the power 4 minus 11x to the power 3 minus 8x squared plus 7x plus 9. Now, we need to make sure everything's in decreasing order, which it is, so we're good there. Now what we do is we take the first value here and divide it by the first value over here. So 10x to the power 4 divided by 2x, you should know, is equals to 5x to the power 3. And so we write that down. So we have 10x to the power 4, because we take 5x to the power 3 times 2x, and then we have negative 15x to the power 3, because again we took this value and multiplied by negative 3. Now you should remember to subtract it, so we get rid of the first term. With the first term equaling to 0, we actually need to get rid of the second term, which it actually comes down to plus 4x to the power 3. The reason why it's 4x to the power 3 is because we had negative 11 minus negative 15, which would mean plus 15. Therefore, it has to be 4. Now, what we see here is we only have one term, and we definitely can't divide it by this whole function, or this whole part. Therefore, we have to bring the next term down. So we brought down negative 8x squared. Again, we perform the same procedure. How many times does 2x go into 4x to the power 3? Well, it goes into it 2x to the power of 2 times, right? Because we took this and divided by that. Now, again, we're gonna do negative. Also, sorry, this should be positive. The reason why this is positive and this is negative is because we're multiplying by a positive value. Okay, so we have 4x to the power 3, and then 2x squared times negative 3 is negative 6x squared. We simplify this and we get 0, and then minus 2x squared. Over here, we have to make sure we're dealing with a negative. Therefore, even though we're subtracting, we're going to be still subtracting a negative value. The way to get a negative value is to, of course, multiply by a negative value. So over here we have negative 2x squared divided by 2x. So our upper value should also be negative x. If we multiply this function by negative x, we get negative 2x squared minus 3x. And over here, we then get 0, and then minus minus plus 10x. And lastly, we'll bring up to 9, so plus 9. So with this left over, we perform our last step. This is a positive, so it's a positive, this has to be plus 5. Oh, sorry. No, that seems right. Did I mess up somewhere? Minus... Oh wait, yeah, over here. This should have been a positive. Sorry, yeah, I did a little oopsie. So over here, since we have a negative, since we timed a negative 3 by negative x, that should be plus 3x. Now we have 0 and 7 minus 3, which is equals to plus 4x. I'm really sorry about that. We'll bring the next term down, and now we'll perform our last step, which over here should be 4x, because 4x divided by 2x is 2, so we'll write down plus 2. Since we have plus 2, we do 4x and then negative 3 times positive 2, and we get negative 6. And over here, we finally get 0 and then plus 3. Or actually, no, we get plus 15 because this is negative and that's a negative, so they make a positive. So what do we have here? We have 15 divided by 2x, which cannot possibly happen. So our final answer would be that when you divide p of x by 2x minus 3, you actually get 5x to the power 3 plus 2x squared minus x plus 2. This is our quotient. And our remainder, so let's actually write quotient, and our remainder would be 15, because that's the value. We couldn't divide it any further. Okay, so now that you know how to do long division, let's move on. With the result of the division, you could know one very important concept, which is the following. The result of the division of a polynomial function p of x by a binomial of the form x minus b can be written as the following. P of x, which is the function, is equals to x minus b times the quotient function plus the remainder. Or it could also be written as p of x divided by x minus b is equals to the quotient plus the remainder divided by the binomial. Both of these forms could be extremely useful for several questions, so you should definitely know the different forms and what they mean. Lastly, to check the results of a division you did, you should of course multiply the divisor by the quotient and add the remainder. If everything goes right, that should equal to your dividend. Essentially, you're just reverse engineering the long division you just did. Now, the remainder theorem. So the remainder theorem states that when a polynomial function p of x is divided by x minus b, the remainder is the value of p of b. Also, the same is true when a function is divided by ax minus b. In this case, however, the remainder is equal to p of b divided by a, where a and b are integers and a cannot equal to 0. Again, the reason why a cannot equal to 0 is because then the whole function wouldn't make any sense, since 0 could not be in the denominator. To show that this theorem works, we will do the following example. find the remainder of the function f of x using long division, and then find the value of f -2 divided by 1. If you're wondering why there's a -2 divided by 1, these are the a and b values, because essentially the -2 is from the +2, and then the 1 is from the coefficient of x, which is 1. Okay, so let's do this example now too. So we have f of x is equals to 3 minus x squared minus 3x plus 1. Okay, now we need to organize it like we had it before. So we have x plus 2. Over here we have 2x3 minus x squared minus 3x plus 1. So now we divide 2x to the power 3 by x, and we get 2x squared. So we subtract 2x to the power 3 minus 2x squared times 2 is plus 4x to the power of 2. Here we subtract negative x minus 4x is equals to negative 5x squared minus 3x minus 5x squared divided by x is equals to negative 5x. So now we subtract negative 5x squared. Negative 5x times positive 2 is equals to negative 10x. So what we get is again 0, and over here negative 3 plus 10 is plus 7x. Last we have our plus 1. So over here we'll have 7x divided by x is plus 7. So minus 7x, and then plus 7 times 2 is plus 14. So what we get is 0 minus 13. Since this is our remainder and this is our quotient, we need to prove that the remainder theorem works. So over here what we got was the remainder is equals to negative 13. So let's do the remainder theorem. The remainder theorem says that if you take the function and then you use the values of b over a and then find what that function equals to at those values, you'll get your remainder. So let's see if that works. So our binomial was x plus 2. Since it was x plus 2, what we need to do is find our a and b value. Our b value is negative 2 and our a value is 1. So we find negative 2 over 1, which is of course equals to f of negative 2. So f of negative 2 is equals to 2 negative 2 to the power of 3 minus negative 2 to the power of 2 minus 3 negative 2 and then plus 1. This equals to 8/16 minus 4 plus 6 plus 1. So what we get is, of course, this is negative 16. So what we get is negative 16 minus 4 minus 20 plus 7 is equals to negative 13. As we could see, the remainders are the same. Therefore, the theory works. Now that we're done with the lesson, this is the homework for today. It is extremely similar to the questions we did today, except some of them involve word problems and or unknown values, but do not worry, I will show you the solution to all of these questions in the next moment. Okay, so let's do question 1. Question 1 is asking us to divide x to the power of 3 plus 3x squared minus 2x plus 5 by x plus 1. So we write x plus 1, and then our dividend, oh, that's a great straight line. X to the power of 3 plus 3x squared minus 2x plus 5. So let's do this quickly. How many times does x go into x to the power of 3? X to the power of 2 times. So then minus x to the power of 3 plus x to the power of 2. 0 minus is 2x squared. Then we bring down the 2x. How many times does x go into 2x squared? Well, it goes into 2 2x times. So then we have minus 2x squared, and then 2x plus times plus 1 is equals to plus 2x. And so we get 0, and then minus 4x. With negative 4x, we have to do minus 4, so we have minus negative 4x, and then negative 4 times plus 1 is negative 4. Also, we forgot to bring down the 5. So what we get is 0, and then plus 5 minus negative 4 is equals to positive 9. And here is our full solution. So from here, it's asking us to write the result in quotient form. Quotient form essentially has our p of x divided by our binomial, which is ax minus b, or x minus b, is equals to our quotient plus the remainder divided by the x minus b part, or ax minus b, however we want it. So here we would have x to the power 3 plus 3x squared minus 2x plus 5, all divided by x plus 1, is equals to the quotient, which we got is x squared plus 2x minus 4 plus our remainder, which is 9, divided by our binomial, which is again plus 1. So this right here is the answer to part A of question 1. So first we need to find the restrictions on the variable. Well, since we see that we're dividing by x plus 1, what x cannot equal to? X cannot equal to 0. Sorry, x plus 1 cannot equal to 0. Therefore, x cannot equal to negative 1. So for part C, we have read the corresponding statement that is used to check, that can be used to check the division. Well, the statement would be just reorganizing and using the other form of the division. So we could have our x to the power 3 plus 3x squared minus 2x plus 5 is actually equals to x plus 1 times x squared plus 2x minus 4, and that would be plus 9. Again, all we did was multiply this whole equation by this part, and then we've rewritten it. This is again our dividend, our divisor, our quotient, and our remainder. Now for part D, verify your answer. So we just need to make sure that this adds up. So let's see. x3 plus 3x squared minus 2x plus 5 is equals to x times x squared. So x to the power 3 plus 2x squared minus 4x. I'm just using the distributive property here. Plus x squared plus 2x minus 4 plus 9, which is equals to, bring up the like terms, 3x, negative 2x plus x, plus, anything else do we have? Oh, sorry, this was plus 2x, sorry about that, plus 3x squared, negative 4 plus 2, so negative 2x, and then we have negative 4 and 9 plus 5. As we could see, the sides equal each other, therefore the answer is correct. Now let's move on to part 3. Actually, we didn't need to do that. Perform each division. Express the result in quotient form. Identify any restriction on the variable. Okay, well, let's go do that. That worked great. Thank you for deleting it. There we go. I love how iffy this is. What is it selecting? Can someone tell me? No? There we go. So for part A, we have x to the power 3 plus 7x squared minus 3x plus 4. So, and that is divided by x plus 2. So x plus 2. So I'm just gonna move this so it looks better. I don't really know why I put it up there in the first place. There you go. And now we're just gonna organize it. Easy. how many times does x go into x cubed? X to the power of 2, easy, minus x to the power of 3, x times 2 is equals to plus 2x squared. I think I'm just gonna run through this. You should know the steps by now, so I don't need to illustrate it to you extremely in detail. So let's go, this plus 9, sorry, minus 5x squared. I'm not gonna write the zeros because they are technically a waste of space. Bring down the term, 5x, so plus 5x minus 5x squared minus, or plus 10x, 0 minus 13x plus 4 minus negative 13x. And this is minus 13. This is minus 26. So this is 0. This is 30. So that is our answer for this question. Does it ask us to express it in quotient form? Yes, it does. So again, let's just quickly manipulate these variables. Quotient form would be our dividend. So this is our dividend all over our divisor, x plus 2, and this is equals to our quotient, which we got at the top, plus 5x minus 13, and then our remainder is plus 30 over x plus 2. Then it asks us to state the restrictions, so we know that x plus 2 cannot equal to 0, therefore x cannot equal to negative 2. There you go. That is part A. Part C and part E are almost the exact same thing. I'm gonna do part C for you just because it is a binomial with an A and a B value, so I feel like it'll give us more practice. It's a little bit more challenging, but I wouldn't say it's a lot more challenging. You know? Oh, that's unfortunate. I can't get these. Kind of sad. Well, let's just scroll down. C. So for C, we have our divisor, which is 5x minus 2 divided by, dividing 10x to the power 3 plus 11 minus 9x squared minus 8x. So here we see they're not organized, so we have to rewrite it again. 5x minus 2 is actually dividing 10x cubed minus 9x squared minus 8x plus 11. Let's run through this. 5x goes into 10x cubed, 2x squared times, so minus 10x cubed, 2 minus 4x squared, 0, negative, negative, minus 5x squared, minus 8x, minus, this is a negative, so this is negative x, negative 5x squared, and negative x times negative 2 is plus 2x. This is 0, this is negative 2 minus 2, sorry, negative 8 minus 2 is negative 10x plus 11, so this is minus 2 again. The again is for minus, so minus 10x, and negative 2 times negative 2 is plus 4. So we get 6. So what we get for this question is actually, oh sorry, this is not 6, this is 7. I can't believe I made such a stupid mistake. So our answer would again be in quotient form, which would be 10x to the power of 3 plus 11 minus 9x squared minus 8x divided by 5x minus 2 is equals to 2x squared minus x minus 2 plus 7 over 5x minus 2, where x cannot equal to, well, 5x minus 2 cannot equal to 0, therefore 5x cannot equal to negative 2, so x cannot equal to 2 over 5. Or sorry, x cannot equal to 2 over 5. Easy. Part E is the exact same question, just reorganize it and follow the same steps I just did. Okay, so we're doing question 4B. I wrote it down over here. what we have to do is just expand and simplify to find the r value. So let's expand first. What we have is x cubed minus 3x squared plus 4x plus 2x squared minus 6x plus 8 plus r is equals to x to the power 3 minus x squared minus 2x minus 1. First of all, we could isolate for r, but rather simplify. We know that these could be immediately removed because they're equal in the values and they're on opposite sides, so when you bring them together, they'll just equal to 0. Now let's isolate for r. R is equals to, let's write down all the values we know it immediately equals to, negative x squared minus 2x minus 1. Then we have plus 3x squared. The reason why it's plus is because we're bringing all these values to the opposite side. So let's do that. Negative 4x minus 2x squared minus 6x minus 8. Again, what we have to do is just simplify. Negative x squared plus 3x squared is 2x squared minus 2x is 0. So we can cross all of these out. They're not needed. Negative 2x minus 4x. Sorry, this would be plus. Negative 2x minus 4x is equals to negative 6 plus 6 is equals to 0. Again, these could get crossed out. So what we have is negative 1 and then negative 8, which is equals to negative 9. Therefore, the remainder is negative 9. Okay, so let's now move on to question 9. So question 9, I assigned B and D. Use the remainder theorem to determine the remainder of each division. So for B, what do we know? We know the dividend and we know the divisor. So from the divisor, we could get our A and B value. Our A value is equals to 1 and our B value is equals to negative 2. Therefore, we now need to find the P of negative 2 divided by 1, which is equals to P of negative 2. So now, since we know that we have to find P of negative 2, we substitute negative 2 into the dividend, and what we get is 2 negative 2x to the power of 3 plus 7 negative 2 to the power of 2 minus x, I forgot we're substituting for a second, minus 2 plus 1. From here we have negative 8 times 2, negative 16, 4 plus 28. And then we have plus 4 plus 2 plus 1. We know that these are equals to 31 is equals to 15. Therefore, the answer for part B is 15. Now, let's move on to part D. Part D is going to be the exact same thing. X is equals to negative x minus 2. So A is equals to 1, B is equals to 2. So we have found P of 2 over 1, which is equals to P of 2. And that is our dividend. So P of 2 is equals to 2 to the power of 4 minus 3, 2 to the power of 2 minus 5 times 2 plus 2. This is equals to 16 minus 12 minus 10 plus 2. This is equals to negative 24, negative 8, negative 22, negative plus 18 is equals to negative 4. Therefore, the remainder is 4. Now let's do question 12. So in question 12, we have the following information. For what value of b would the polynomial function of the form as following have the same remainder when it is divided by x minus 2 and by x plus 2? So what we have is our divisors. We know that from the remainder theorem, p of the first divisor, which would be 2, would have to equals to p of the second divisor, which would be negative 1. From here, we need to just substitute those values in and evaluate. So p of 2 is equals to negative 2 to the power of 3 plus b 2 to the power of 2 minus 5 times 2 plus 2. And that is also equals to p of negative 1. So negative 2 times 1, negative 1 to the power of 3 plus b negative 1 to the power of 2 minus 5 times negative 1 plus 2. Now let's simplify these expressions. So we have negative 16 plus 4b minus 10 plus 2 is equals to 2 plus b plus 5 plus 2. These together would make negative 24 plus 4b is equals to 9 plus b. Let's move all the b's and all the numbers to one side. So we have 3b is equals to 9 minus negative 24, which is equals to 33. So b is equals to 11. Therefore, the b value will have to be 11. Next, let's do question 16. Question 16 asks us the following. For first, determine the remainder when 6x cubed plus 23x squared minus 6x minus 8 is divided by 3x minus 2. What information does the remainder provide us about 3x minus 2? And then express that in factored form. So first of all, we can easily find the remainder using the remainder theorem. So we don't have to go through long division. So what we know is p of x is equals to our function 6x cubed plus 23x squared minus 6x minus 8. It is also very important to say let p of x equal that. Now, since we have our function, what we could do is find the a and b value, which in our case a is equals to 3 and b is equals to 2. So then we are finding p of 2 over 3, which is equals to 6, 2 over 3 cubed plus 23, 2 over 3 squared minus 6, 2 over 3 minus 8. Using a calculator, we can easily find that this value equals the following. It is equals to 16 over 9 plus 92 over 9 minus 4 minus 8, which is actually equals to 0. This is a wonderful case, since now we can determine what the second part is asking us. The information that this divisor is telling us is that it is a perfect factor of the dividend. It perfectly goes into the function. Therefore, that's all we have to say. It is a factor. 3x minus 2 is a factor of the function. I'm too lazy to write it, but I think you understand. Now, what we need to do is express it in factored form. Sadly, this is the part where we actually need to go and do long division. So let's do that. See, we have 2x 3x minus 2 dividing 6x to the power 3 plus 23x squared minus 6x minus 8. First of all, we have 2x squared minus 6x to the power 3, that times that is equals to negative 4x squared. So we get 0, and we get plus 27x squared minus 6x. 27x squared is the same as multiplying that function by 9x. So now we have minus 27x squared and then minus 18x. What we get this time is plus, which is 0, plus is equals to positive 12x minus 8. Lastly, we have 12x and 3x, which would be plus 4. Multiplying the whole equation by plus 4, we get 12x minus 8, which is equals to 0. Therefore, the remainder is 0. So now we have that as our quotient. The factored form would be 3x minus 2 times the quotient, which is 2x squared plus 9x plus 4 is equals to what we had already. Now we just need to factor the quotient. The quotient is rather easy to factor, since we know how to do these sorts of factoring. So we have 2 and 4, so we're multiplying it to 8, and we're adding it to 9. So what we could write is 3x minus 2 times 2x squared plus 8x plus x plus 4. This, of course, is equals to 3x minus 2, and then we move the 2x out, minus, we're left over with an x, and we are left over with a 4, and this is also plus 1, x plus 4. So now we have our full factor form, 3x minus 2, then we put these together, 2x plus 1, x plus 4. That is our full factored form of this function. Now that we're done solving all these questions, I'd like to thank you for listening to my whole lesson. I hope you've learned a lot once again, and I will see you soon for part 2.2 of this textbook.